2-4 is doing deductive reasoning. We talked about inductive reasoning in 2-1. 2-4 is deductive reasoning. So inductive is reasoning based on a pattern that you see. Deductive reasoning is reasoning based on statements that you see. So it's like, they're telling me this, therefore this must be true. Okay, so deductive reasoning, slightly different. We're going to talk about two types of deductive reasoning. And it's really two laws that come into play. The first law is the law of detachment. The second law is the law of syllogism. And that one might show up for you in English class at some point. I think at least maybe in the AP class, the junior AP. She was just talking to me about how they're talking about law of syllogism. Or not law of, but syllogism. So you may come across this again at some point in your life. But this stuff, law of detachment and law of syllogism, it's really very practical for life. It's about being a good reasoner and thinking through what is logical, what makes sense in a situation, okay? And really just even like conversations with your parents. If they say, if you do this, then this happens, and they don't follow through one way or the other, it's, you know, there's reasonability involved with that. So here it is. Law of detachment says if a conditional is true, so if an if-then statement is true, and they tell you the hypothesis of that statement is true, then you can conclude that the conclusion is true. Basically, that's to say this. If P then Q is true, and we tell you that P is true, then your conclusion that you can make is that Q is true. Okay, and I'm going to give you an example right now of where this works and where it doesn't, just so you can see if the law of detachment is actually happening or not in a problem. So first example says this. If a student gets an A on a final exam, then the student will pass the course. Okay, so there's your conditional statement. There's your if P then Q. And so we're saying that's true. If a student gets an A on the final, they're going to pass the course because the final is worth so much of their grade that there's no way to fail the course. Okay? The next statement says Susie got an A on her history final. And if you notice, that corresponds to that hypothesis of the first statement, right? It says if a student gets an A on the final, Susie got an A on her history final. We're really saying the same thing there, right? So this is if P then Q. They gave us that P is true, so we can conclude what? Susie passed the course. Or you could say Susie passed history since they told us it was her history. So either way, Susie passed the course, Susie passed her history course. I would take either of those. So that is what law of detachment should look like if it's going to work the way that we want it to work, okay? How about this second one? If you have a license, then you can legally drive a car, okay? So if you have a license as your hypothesis, you can legally drive a car is your conclusion. The next statement says you drove to the store.
You have a license. You have a license. No, you don't.
Not necessarily. You could just be driving around. Funny story for you. When my mom was like, 14 years old, her dad was a smoker, and her mom passed away when she was a little girl. So it was just like her dad, and her little brother. And he'd be like, hey, run to the store and get me some cigarettes. And she was 13. She would drive to the store, get him some cigarettes. I don't know why they sold a 13-year-old cigarettes, but things were different back in the day. And drive back home. Did she have a license? No. So this says if you have a license, then you can legally drive a car. This is the conclusion back, right? That's the conclusion portion. If it goes hypothesis, conclusion, you have to say not possible because she might be my mom driving illegal to the store. Okay? So that is law of detachment. Questions on that? Okay, so if I said, if you all get an A in my class, then I'll give you candy at the end of the year. And I said, everyone got an A. Your conclusion would be, you're all getting candy, right? But if I said, if you all get an A in my class, then I'll give you candy at the end of the year. And last day of school, I just start throwing candy around. What do you say? Not possible, because I might be giving you candy because everyone got an A, but I might just be giving you candy because I really like you, right? Or because it's the last day of school. So just make sure the if and the then, right? The statement that you start with is a true statement. Your next statement is true for the hypothesis, then your conclusion will be true, okay? So if P then Q, P is true, you conclude Q is true. All right, law of syllogism. This one says if P then Q, if Q then R, you take out the Q's and you say if P then R, okay? So you have to get rid of a matching hypothesis and a conclusion. If they're both hypotheses, you're not going to get a statement back. If they're both conclusions, you're not going to get a statement back. That makes sense. So here's our first example. If a figure is a square, then the figure is a rectangle. Okay? If a figure is a rectangle, then the figure has 4 sides. The two statements that are the same are which two? The rectangle. So what you do is you get rid of the rectangle. What statement are you left with?
The square has 4 sides. If the figure is a square, then the figure has 4 sides.
Right. If a figure is a square, then the figure, should have given you more lines, sorry, has 4 sides. Okay, which will be a true statement then. Okay, look at B here. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. What's the same? Flexible, right? So if we get rid of our flexible statements, then you are flexible, then you are flexible. What are you left with? If you do gymnastics, if you do ballet. Does that make sense? No. So if we're left with 2 hypotheses, you have to say not possible. That is not an if-then statement. There's nothing true to give there. If you're left with 2 conclusions, you say not possible. Once you take the 2 that are the same out, you have to be left with a hypothesis and a conclusion, and then you can make that statement. Okay, Maddie?
Will the hypothesis and the conclusion that you're left with, will they always be true?
Yes. Yeah, because you're allowed to assume that the initial statements are true. So as long as we're assuming that the first statements are true, then the statement it makes will also have to be true. Okay? Yeah, Heather. Lost it? If you, yeah, come back if you need to. Okay. Here's another one. And I wrote a while instead of a whole. Sorry, this is whole. If a whole number is divisible by 10, then it's divisible by 5. If a whole number ends in 0, then it's divisible by 10. So both of those are true statements. What are the 2 that are the same? Divisible by 10. So we're going to take away then it is divisible by 10, and if a whole number is divisible by 10, what's the statement you're left with? Right. So here's the deal. It's in a different order, right? You always want the if and then the then. It just makes more sense that way. So even though the if statement came second, you're going to write it first. So we're going to say if a whole number ends in 0, then it's divisible by 5. Okay, if a whole number ends in 0, then it's divisible by 5. So that's law of syllogism, sorry. Take out the two that are the same, and you should be left with an if-then statement that you can make your conclusion. Okay, sometimes it takes both of those laws, syllogism and detachment, and puts them together. And when that's the case, you have to do syllogism first and detachment second. Otherwise, it's not going to make sense. So just keep that in mind. Syllogism first, detachment second. So if you look at this example, if you live in Cerritos, then you live in California. If you live in California, then you live in the U.S. James lives in Cerritos. We want to make a conclusion. Anyone see the conclusion right now?
James lives in California.
James lives
United States.
in the U.S. Okay? Here's why. If we're going to do law of syllogism is going to involve these two statements, right? Law of syllogism is always two if-thens. What's the same about those if-thens? California. So we're going to get rid of California. Sometimes I would like to get rid of California, let me tell you. Not the weather. Just a lot of other things about it. All right, so your new statement is what? If you live in Cerritos, then you live in the U.S., okay? Now we're going to do law of detachment with it. So if you live in Cerritos, then you live in the U.S. James lives in Cerritos. James lives in the U.S. is your conclusion. So just make sure you're doing the whole if P, basically it's this, right? If P then Q, if Q then R, P is true, is your setup. So we're going to first take away the Q's, and then all the rest of this is giving us law of detachment. So we're going to say Q is true. Okay? Any questions on that? All right.